Hello everybody. Uh, at long last, we're going to take a look at the answers to the page 370 assignment. I have discovered, much to my consternation, that my camera, my phone, is cutting me off at about 30 minutes. So I need to write down my start time, and I don't want to go past 11:24. Okay. So I may have to cut this into two parts. Part one being going over page 370, and part two, which will be a separate video, introducing some new material and a new assignment. Oh, by the way, regarding Google Classroom, there really is not much of anything posted on Google Classroom for right now. I'm concentrating on getting used to using email and RenWeb and, of course, YouTube videos. That may change in the future, but for right now, there's nothing worth looking at on Google Classroom. But the code, if you want to get into it, is JIGG35 and the lowercase letter L. JIGG35L. All right, there you have it. Okay, we're going to play a little game as we go here. The game is, can you find the rubber chicken someplace in this video? All right, so we move on. Looking at page 370, we will start now with number 50. Number 50 is asking for all 6 trigonometric functions of 5 pi over 6. All right, first we need to figure out where in the world is 5 pi over 6. As you know, we have 0, we have 2 pi, then we have 1/2 pi, that makes sense. Halfway between 0 and 1/2, we have 1/4 pi, right there, the yellow one. Sorry about that little slash, okay. Then, 1/3 of the way up from what we would call 90 degrees, we have 30 degrees, which is pi over 6. Double that, we would have 2 pi over 6, which is actually pi over 3. So to find 5 pi over 6, let's count by sixths. That's 1/6 pi, 2/6, 3/6, 4/6, 5/6. We're sitting right here. We make our little right triangle. So that is what kind of angle? That would be 30, 60, 90, 120, and 150 degrees. Better known as 30 degrees from the horizontal. If this is 150, this must be 30. So we're talking about a 30-60 triangle. Again, it is your responsibility to know the relationships, the ratios for 30-60 triangles. If the hypotenuse is 1, because this is a unit circle, then the short leg is going to be 1/2. The long leg will be 1/2 square root of 3, better known as square root of 3 over 2. So that means the coordinates of this point are, well, let's call that negative square root of 3 over 2. The coordinates of that point would be negative square root of 3 over 2 and 1/2. The coordinates of this point, negative square root of 3 over 2, 1/2, right there. Then for the sign, you can think of it using SOHCAHTOA. SOHCAHTOA, my old Indian friend. Or you can think of it in terms of the coordinates of the point. So for sine is going to be your second coordinate. 1/2, that's all there is to that. Or opposite over hypotenuse. Opposite over hypotenuse. 1/2 over 1. 1/2 over 1, 1/2. Excuse me, cosine is the x-coordinate. Negative square root of 3 over 2. Negative square root of 3 over 2. Or cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. There we go. Negative square root of 3 over 2. Then tangent being the y value over the x value, or tangent being opposite over adjacent. The tangent would therefore be, I need some space here. I think we can get rid of this now. The tangent is going to be 1/2 over negative square root of 3 over 2. Of course, we can't leave it that way. We have to change the division into multiplication by the reciprocal. That becomes 1/2 times 2 over negative square root of 3. The 2's cancel. What do we end up with? 1 over negative square root of 3. But, of course, complications. We can't leave that way either. We have to change that into proper fractional form. We have to get rid of the radical in the denominator. So we take our negative 1 over square root of 3, multiply by square root of 3 over square root of 3, and we end up with negative square root of 3 over 3. And we finally got it, negative square root of 3 over 3. Whether thinking of it in terms of 1/2 over negative square root of 3 over 2, here, or whether think of it as opposite over adjacent, which I've obliterated, but opposite over adjacent. Either way, we get negative square root of 3 over 3. Now for the remainder of these guys, cotangent, this is one of those things that the textbook does not mention, and that is that these are reciprocals, and these are reciprocals. Therefore, and it works that way when the functions are written in what I call the natural order. The book does not list them in the natural order. I think the author simply wasn't thinking. But when listed in the natural order, it's very easy to see what is the reciprocal of what. So for cosecant, for example, cosecant is just the reciprocal of 1/2, which is going to be 2. The secant is the reciprocal of negative square root of 3 over 2, which is negative 2 over square root of 3. But you know the story on that. We can't leave that radical down there. So we multiply by square root of 3 over square root of 3, which gives us a final result of what? Negative 2 square root of 3 over 3. Negative 2 square root of 3 over 3. By the way, any place along the way, ordinarily when I make a mistake, which happens almost daily, when I make a mistake, somebody out there says, "Mr. Beer," and I say, "Yes," and they say, "You messed up on blah, blah, blah," and "Oh, I'm so sorry I messed up. How could I do such a thing?" Well, if I make a mistake here, I'm talking to an empty room. There's no one to correct me. So if I mess something up, please send me an email indicating where I went wrong, and I will publish a retraction, a correction. By the way, please try to resist sending me irrelevant emails. I'm receiving like 85 emails a day of homework assignments, and my inbox is really chaotic. And I would rather not get little things like "thanks," because then I've got to find that, say, what's this? Click on that, open it up, all it says is "thanks," okay? And then put it in the trash and then move on. That really slows me down. So please keep the emails restricted to important things such as homework posts or urgent questions that you could not answer for yourself. Or for corrections of my mistakes. So anyway, back to this. For the cotangent, cotangent is the reciprocal of tangent. So I take this guy, negative 3 over square root of 3, and flip it upside down, and then multiply by square root of 3 over square root of 3. Well, nice things happen here because this becomes 3. These 3's cancel, so we get negative square root of 3. Negative square root of 3. I erased secant. What was secant? Well, I had it there. You know what it was. Okay, that is the general procedure. Now, for the remainder of this assignment, or almost all of the remainder of the assignment, I am not going to go through the glorious details. I will comment on number 52. How do you find 240 degrees? To find 240 degrees, this is number 52. There. Whoops, sorry. you saw a brief glimpse of how much email I have to wade through. Okay, so 240, what we're doing, 240. This, of course, is 180. We have to go another 60 degrees past that. Another 60 degrees would take me to here. This would be 240 degrees. And that means that my 30-60 triangle is sitting here like this. This is the 30-degree angle, this is the 60. If that's 1, I'm sorry, let me put this where it really belongs, that's better. So if that's 60 and that's 30, this is 1, this is negative 1/2. Why negative? Because I'm going to the left to get here. Negative 1/2, and this is negative square root of 3 over 2. That's a 3, really. There we go. Negative square root of 3 over 2. That's how we locate it. So the coordinates at this point become negative 1/2 and negative square root of 3 over 2. And we go from there to find all 6 functions. By the way, remember, all students take chemistry. Let me clear this and remind you of how that works. All students take chemistry. All 6 functions are positive in this quadrant. In the second quadrant, only sine and its reciprocal cosecant. Only sine is positive, the rest are negative. In the third quadrant, only tangent and its reciprocal cotangent. Only tangent is positive, the rest are negative. And in the fourth quadrant, only cosine and its reciprocal secant. Only cosine is positive, the rest are negative. So that can be very helpful. Eliminates having to worry about whether your coordinates are positive or negative. Using SOHCAHTOA and not worrying about the positives and the negatives, simply giving it a sign in the end. But don't forget, I find some folks who use this method, they tend to forget in the end to assign the correct sign to it, and the ones that should be negative, you forget to make them negative. So if you're going to use this, just don't forget to use it in the end. All right, from here on out, I'm simply going to read answers from the back of the book to save time. Number 52, your answers are, according to Mr. Sullivan, sine, negative square root of 3 over 2. Cosine, negative 1/2. Tangent, square root of 3. Cotangent, square root of 3 over 3. Secant, negative 2. And cosecant, 2 square root of 3 over 3. That was all for number 52. Now we'll go on to what's next. 58. For number 58, 390 degrees. For 390, of course, on the unit circle, you're going to go all the way around once, and then you're going to go around, I did it the right direction, I'm thinking backwards. You're going to go all the way around once, that's 360, and we're going to 390, right? 390, yes, which means we go another 30 degrees, so we're sitting here at 30 degrees. You've got your 1, your 1/2, and your square root of 3 over 2. So for number 58, sine of 390 is 1/2. Cosine is square root of 3 over 2. Tangent is square root of 3 over 3. Cosecant, oh no, let's go in the natural order. Cotangent is square root of 3. Secant is 390. And cosecant is 2. Moving on to number 50, no, that was 58, 64. Number 64, this looks like, yes, more of the same thing. 5 pi, where is 5 pi? 5 pi would be 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Remember remember the trick. An odd number of pi will be here at 180. An even number of pi will take you back to 0 again, or 2 pi. So we're sitting here. What's the trick for this one? The last time we met, I emphasized that if you have a hard time seeing what this should be, first of all, you can just go with coordinates. The coordinates are simply -1, 0, and do it by coordinates. Or if you prefer using the triangle method, make a little triangle here, just understanding that the hypotenuse is 1, the adjacent side is -1, but the opposite side is actually 0. So we draw a little pretend triangle here. The triangle should actually be laying flat with the side of 0, but so we can see it, we open it up a little bit with the understanding that that opposite side actually does not exist, so it has a length of 0. We have opposite, adjacent, and hypotenuse, so you can use SOHCAHTOA, or just use the coordinates. So for number, and I've lost it now, which one are we on? This is number 64. Number 64, sine of 5 pi is 0. Cosine is -1. -1, watch out for the signs. Tangent is 0. Cotangent is undefined because you can't divide by 0. Secant is -1, and cosecant is undefined because you can't find the reciprocal of 0. It doesn't exist. You can't divide by 0. A number. How am I doing on time? Okay, I'm fine so far. That was 64. Number 68. 68. And so, yes, this one we're simply using the calculator. We're punching in for number 68. What are we doing? For 68, we are looking for the cosine of 14. All right, again, folks, as I emphasized the last time we were together, on your calculator, whether it's a Casio or a TI-83, whatever you're using, you have to make sure you're in the right mode. In this case, you need to set your mode to, and I've already forgotten where we are, number 68. 68 is given to you in degrees. You have to make sure your calculator is set for degrees. I'm not going to go through that procedure right now with you. Basically, hit your mode button and select degrees. If you want to see more detail, you can probably find a YouTube video on how to do that. It's very simple. Same thing with the Casio or any other calculator. Make sure it's set for degrees. Calculators come from the factory normally preset for radians, so you need to change it to degrees. Then you just punch in cosine of 14, and the instructions ask for 2 decimal places. So my answer here says you round it off to 0.97. If you got something way off from 0.97, it could be that you were not set for degrees, but you were set for radians. Make sure you're in degrees and try again. Number 70. We have cotangent, or did I assign someone to, where are we next? Yes, 70 was assigned. Cotangent of 70. For cotangent, what are you going to do? The calculator doesn't have cotangent on it. Well, you're simply going to find tangent and then do the reciprocal. 1 over the tangent of 70. You can just, on the calculator, just do 1 divided by, and then say tangent of 70. Bang, you've got it. It comes out to 0.36. Make sure you can get 0.36 out of the cotangent of 70. By the way, speaking of, there was something with my mind. Oh, bummer, I've forgotten what it was already. It comes and goes so quickly at my age. Number 7, let's move on to number 74. 74, cosine of pi over 8. Well, that's radians. So now you have to switch your calculator back to radians. Same way you set it for degrees, go through the mode key, change it to radians now. How do we know it's radians? Oh, I'm glad you asked. Because there's no degree sign, and there is a pi in it. Pi over 8, you know it's radians. So we're going to do cosine of, and on the calculator, you may have to, depends on the calculator, you may have to hit the cosine key, and then hit, it'll probably provide a left parenthesis for you. If it doesn't, hit the left parenthesis key, and then do your pi. You have a pi key. Find your pi key. Hit your pi key, and then divide by, and then I forgot what was already, 8. And then hit your right parenthesis key. That'll give you the cosine of pi divided by 8. The parentheses become important because without the parenthesis, it's going to give you the cosine of pi, and then take the entire answer and divide by 8. That's not what you want. You need to make sure the calculator is doing pi divided by 8 first. So use the parentheses on your calculator. Oh, and of course you'll hit the equal sign. Other calculators may do it other ways, but just be very careful that you're actually finding the pi, the cosine of pi over 8, not the cosine of pi, all divided by 8. Be careful. You get 0.92. Number, after 74, we have 76. I just remembered what it was I was going to tell you. I better say it now before I forget. And that is, I am not going to be able to check all of your papers for every detail. I spot check. I take a look at your paper. I ask myself the question, do they look like they know what they're doing? Do I see a couple of right answers here? Sometimes I'll slow down and look more carefully if I think I need to. If I see a lot of wrong answers, I'll slow down and look more carefully. I may or may not respond to you by email, but I am not checking everything in detail. So you may have a 4 in RenWeb, 4 out of 4 points, but that does not necessarily mean that your paper was good. So that's why you are checking your paper now. Number 76, there it is. I don't have the answers written in here, so going to the back of the book, 76 even, 76, there it is. Nope, wrong page. Here it is. 76. My book says 5.67. 5.67. Again, for cotangent, you're going to find tangent and then give me the reciprocal of tangent. By the way, cotangent of something just hit me. I don't think you would do this, but just to make sure. Cotangent of pi over 18 is not the tangent of 18 over pi. That's downright silly. Never think about that again. Don't even look at that. Okay. Rather, you want to find the tangent of pi over 18 and then give me the reciprocal of that. Easiest way on the calculator, put in a 1, then divide by, and then tangent of pi over 18. That will do it. Or you could just find tangent of pi over 18 and then form the reciprocal of that. You do have a reciprocal key on your calculator. It looks like this. It will give you the reciprocal of whatever you put in. Okay, now, that was 76. Hoping I'm not skipping anything here. 76, there's 5.67. Okay, and 84. 84 I circled in my book because for some reason there's a good reason to take a closer look at 84. Oh yes, I knew what 84 was. The problem with 84 is it's not a unit circle. Oh no, what are we to do? Well, we went over this again. Last time we were together, we saw one like this. We're looking at the point 5, negative 12. All right, let's estimate where 5, negative 12 is. 5, negative 12 would be someplace down here. 5, negative 12. All right, so what are we going to do? We make a right triangle. We know that this is negative 5. We know that this is negative 12. Well, we have to take a few moments to find out what this is. Now, some of you may have memorized from back in your geometry days a special relationship. If you've got a right triangle whose legs are 5 and 12, you know the hypotenuse is going to be 13 automatically. So this is not a unit circle. It's a 13 circle, okay? How do you do that if you don't happen to know the 5, 12, 13 ratio? Well, you could do 5 squared plus 12 squared equals your x squared. That's 25 plus 144 is x squared. That's 169 is x squared. Therefore, x is the square root of 169, which happens to be 13. It works. So now we know all three sides. Now you use SOHCAHTOA to find your functions. For instance, sine of your theta will be opposite over hypotenuse, which is negative square root of 12 over 13, so it's negative 12 thirteenths. Cosine of theta, SOHCAHTOA, C-A-H, cosine is adjacent over hypotenuse, that's negative 5 thirteenths. Tangent of theta will be opposite over adjacent, SOHCAHTOA, T-O-A, opposite over adjacent, that's opposite over adjacent, that's negative 12 over negative 5, which is 12 fifths. And then the cotangent, these are easy, because the cotangent is just the reciprocal of tangent, 5 twelfths. The secant is simply the reciprocal of cosine, which is going to be negative 13 over 5. And finally, the cosecant of theta will be the reciprocal of sine, which is negative 13 twelfths. Negative 13 twelfths. And I'm trusting that I got all of those correct without any silly blunders. So that's how to handle it when the coordinates of this point do not happen to fit on the unit circle, meaning that it's not a unit circle, meaning that you've got to find out what the hypotenuse is. Okay, that ends that, and it looks like I am within my 30-minute time frame here, so I will sign off for this one. Please check in again, perhaps later today, for my posting of the new material for the day and a new assignment. The new assignment, assuming that I get it produced for you before 3 o'clock, the new assignment will be due by noon tomorrow, noon on Thursday. Anything that's turned in after noon on Thursday would be considered late. So I'll present that new material and give you the assignment later in a second video for the day. Anything else I needed to mention to you? I don't think so. I believe we've covered it all. Oh, did you find the rubber chicken? And that's it for now. Goodbye.